So today we're going to look at Common Core Lesson 7 notes. We should be understanding proportional relationships. I want you to think through to last year. So kind of thinking about last year and what proportions involved. Proportions, for the most part, last year, you would have, two equal fractions. And you were probably shown how to cross multiply, and divide. And we're going to relate that to lines and graphs, which you've been working on. So a proportion is an equation in which two ratios are equal. So which two ratios are equal. Let's make that R a little bit better. And when two ratios are equal, they have what we call a proportional relationship. Proportional relationship. So we have an example of a graph below. The example of a proportional relationship is represented below. So this graph illustrates a person driving a car at a constant speed. So we're looking at this graph here. Traveling in a car. Driving a car at a constant speed of 50 miles per hour, and the time is in hours, is represented on the x-axis. So if you look below on the x-axis here, time in hours. And then the number of miles is represented on the y-axis. Again, that number of miles here represented on the y-axis. All graphs of proportional relationships have two things that are true. They pass through the origin, and what that means is they pass through that 0, 0 point. That is a reminder that that is the origin, and we see that right here. So we're looking at that point being 0, 0 is the origin. So if graphs are proportional in relationship, they pass through the origin. And the other statement that is true of all graphs that have proportional relationships is that they form a straight line. Which at this point you have a lot of experience with. Is that another word for that is linear, and you've been dealing with linear equations. A rate of change is a comparison of two quantities that are changing. And again, this relates to the graph that we see on the right, because this is an example of that. The rate of change is 50 miles for every hour. So we have two quantities, miles and hours, and they are both changing. The miles are increasing and the hours are increasing, so they are changing as we look at the graph. For this example, the rate of change is 50 miles for every hour, and so we can write that as a fraction, 50 over 1, which is equal to 50. And that is a unit rate. A unit rate is a ratio, so that's two equal fractions, of measurements where the second measurement is 1 unit. So you can see that's where that word unit rate comes from. So 1 unit, and and the second value then is for 1 of something. This is the same as the rate of change. So in this case, the unit rate for our graph is 50 miles for 1 hour. So the unit rate is 50 miles per hour, or 50 miles for 1 hour. So the points 0, 0, and 150, we can use that to find the slope. So rate of change is another way to kind of look at slope. And you're very familiar at this point of how to find slope from 2 points. So just reminding you that's change in y over change in x. So we'll take our y minus y, second y minus first y, over our second x minus first x. And so that, of course, gives us that slope of 50 over 1, or 50. So again, noticing that we now have 3 different descriptions for kind of the same quantity. That we have rate of change, we have the word unit rate, or the phrase unit rate, and the words slope are all the same.